everybody, and welcome to this month's edition of Ham Talk, sponsored as always by the Hamsters Week Signal Group. And apparently, this might be the pet episode because I'm at the house, as you can see, and my cats are meowing in the background. Greg has the dog. I think Melissa's fighting her cats. I'm not sure. There might be horses and zebras involved too, because God knows what the hell Andrea has.
Just a cat.
Yeah, she claims just a cat, but you don't know what's in the backyard, okay? So we're really happy that you guys could join us. I have actual notes here because if I don't pull this note up on what is going to be covered in Greg's section, I'm not going to know how to say it. So I'm joining you this month, Melissa. It's okay. Okay, so Greg is going to be doing quadrifilar helix antennas. I think I said that right. Melissa, what have you got for us this month?
I have comments and questions.
Yes. I love comments and questions. I wish I had time to get to them, but I will tell you people, when your deputy director goes on 6-month leave of absence for the military and leaves you right when it's time to write the budget, don't have time for much of anything right now.
Mm-mm.
I carved this hour out for you guys. I was like, everybody leave me alone, be quiet. I must record right now. So, Andrea, what do you have for us this month?
I don't know.
Oh, it's going to be a surprise. Oh, I know you're going to tell us the story about the hotel room. I know you're going to do that.
If you want to hear that, well, I'll talk about that.
It just
And
fits
as
in
for
with the
me,
weird things that happened to you.
Seriously, it's a running theme through the show, Andrea. You have to give us something weird. So as for me, I actually have something interesting to share. It is ham radio related, but it's not directly ham radio related. By the end of this year, we're reviewing our local emergency operations plan and once again discussing forms of communication under our emergency support function 2, communications. So I will be talking a little bit about that. I am hopefully going to have someone, a guest, in interviewing me. So it'll be interview style. And tomorrow, because I didn't cram enough into my beginning of my week already, I will actually be at Fort Leonard Wood helping to train the Civil Air Patrol on the Community Emergency Response Team, or CERT. And I am positive that at least one of those guys is an amateur radio operator. So if I can, I'm going to grab whichever one I can find, because I am willing to bet like my left arm on this, okay, that one of these guys is a ham radio operator. And if they're available and I can carve out a little piece of their time, I'm going to sneak in a little interview with them. Shh, don't tell anybody, because they've got a 12-hour training day tomorrow and mine's only 8 of it.
JD, you got audio yet?
He's trying.
At least when I come back, I have got 5,000 things to update you guys on, because I'm not busy enough at all. I also stepped back into my role as public information officer for the Missouri CERT Association. So you know, I just love doing all this stuff. No problem. It's one of those situations where if you don't volunteer, you're going to be voluntold. I don't know if you guys have heard of that word yet, but I'm going to introduce all of our viewers to that word, because if you're in Aries, it's going to happen to you too. You will be voluntold to do something if you don't volunteer to do it. And it affects all of us. Right? Yeah, this could be in your paid job. This could be in a volunteer position. You're going to get voluntold to do something.
JD, I think you're still having problems with audio because we don't.
Maybe you won't hear me.
There you go.
There we go. All right.
We have JD in the house.
Now that JD's here, and I've done a rambling introduction without introducing us, because we're hoping that we're always getting new people following us and new people tuning in. JD, the camera is focused on your background, not your foreground. There you go. Put your finger towards the camera. Whoop. We're gonna count
There you
JD's
go. There
nose
you
hairs
go.
this month.
There you go.
Don't
That's
touch
All
better.
right, now we can do our
Ah.
round of introductions.
And then he
because
gets,
maybe we don't need introductions at this point. All right, we'll start with myself. I am Sam, KE0LMY. Miss Melissa.
hi, KI5ICQ.
Greg.
Greg, N5XO.
Ms. Andrea.
Hello, Kilo 2, Ecto Zulu.
I love that. That's probably my favorite part of the intros. And then, of course, JD.
JD, W1BBC.
Awesome.
It's whiskey
All
one.
right.
Victor Zulu, sir.
So, Greg, you get to start us off this month. Tell us a little bit about this. Wow. I'm not going to say that again.
I'll tell you
About
what,
this Helix antenna.
I'm going to tell you right now, I'm ignorant on it. Tomorrow at the hamster meeting, we are doing a training on the design, building, and use of that antenna. And I'm not even going to try to pronounce it because, like I told you earlier, Sam is too many syllables.
He did say
Say-
that.
Say it, Andrea. What is it?
A quadrifilar?
There you go.
Helix.
There you go. Let the professionals handle it. I'm just here to be pretty and talk a lot. It's fine.
Maybe a health beverage.
Hey, if it brings people in, I don't mind. I'll be the face. It'll be fine.
This would explain the glasses.
Yeah, Mr. Aviator's here.
Why?
Oh yeah. Oh yeah.
All
He's
right.
looking sharp. All right, Melissa. And then as I understand it, you have some comments and or questions for us this month. What do you have for us?
Are we ready?
Yeah, I think so.
Right.
Let's dive right
Okay.
into it.
Let's do it. This past month on the last show, we have some comments from the Ham Man BS4KS. He says, okay, I may be creating a firestorm with this question, LOL. As most know, I just got a new Tram 1481 base antenna. It is 50 feet in the air. Now here it comes. I have people telling me you got to ground it, and oh my goodness, you got to ground it. My pipe is 4 feet in the ground, no concrete, but it has support and it isn't going anywhere, that's for sure. But I have a guy telling me I still have to ground it. The pipe is 4.5 feet underground. To me, that should be enough ground. Am I wrong, or do I need to get an 8-foot grounding rod and beat it into the ground and run wire?
Andrea? You noticed that was a quick volley.
Oh, I'm not an expert on that. People will tell you have to get it down. I'll take whatever ground I can get.
The answer to that is, what does it have the ground conductivity? God, I can't talk at all today.
Conducted.
I
The
just want to
ground's
point out.
conductivity and stuff. Because like my ground out here, I've got 12 16-foot ground rods sunk in.
Mm.
And I had to use a big giant hammer drill to drive those suckers in because the clay, the rock, and
Yeah.
the 1/4 inch of topsoil I have. Plus what we did is I took a tractor and an auger and drilled 3.5-foot holes before I drove the ground rods in,
Yeah.
and then filled those holes with ground enhancing material.
Oh, wow.
And I
Well-
measured my goal was to get under
Well,
10 ohms between each ground rod. So they're equally spaced.
So
but
the
4
question
foot in the
is,
ground's not going to do it especially with your mast. For one, it's just not going to do it.
yeah,
Unless
because
you live
if,
at the ocean.
yeah, I was gonna say, if that sucker gets hit by lightning, it's gonna run right up the cable into the house. So Wouldn't
That
wouldn't
can
your
happen
ground,
with anything as far as ground goes, unless you have very, very specific suppression.
right,
So
right.
Mhm.
And let me add one other comment, maybe two. Since I don't have Greg's budget for ground enhancing material, I put down a 25-pound bag of rock salt and drive my ground rod through that, and it leaches into the soil over time. Number two, use at least 1-inch wide copper strap from your shack to the tower, not round wire, so it doesn't resonate on HF bands.
Ooh, that was a good hint.
Get Georgia Copper in Atlanta, Georgia. The great resource, georgiacopper.com.
There you go. Ooh,
So-
little plug there.
Yeah, the other, oh, go ahead, Andrea.
I was gonna say, in my defense, rovers don't have grounds.
What did you say?
Something about Rover not grounded.
Oh,
Rovers
Uh,
don't have grounds.
Yeah.
Especially not when they wreck.
The things I recommend for any antennas, use a DC ground antenna. Put a surge protector to bleed off any stray static charges. I'll give you an idea how much static charge can build up on a regular antenna. I had a 48 element loop Yagi on 1296, and I had the antenna up, but I hadn't run the hard line to the top of the tower yet. So I just had the jumper cable hanging down from the antenna for the rotor loop. I climbed up, and when I grabbed that, it bit me. When I grabbed the cable hanging down,
was it a
like,
day?
huh?
Was it a
It was
windy
a
day?
slightly breezy day, but nothing major. And when I took that and grounded it, I actually was like an arc welder. I went down and I had a nice burnt trace down the mast of the pole. It didn't cut into it or anything, but that's enough current to do that. So, you know, I always have surge protectors at the top and surge protectors at the bottom. They're not going to protect you from a direct lightning strike or even
Right.
a real close one. But what they do is they keep that static charge burned off and help keep it down. And then, like I said, on our house, we have 16 ground rods spaced they're 12 feet deep, 16 of them, 12 feet apart.
And while this may not come from a professional, I will tell you what I do a lot, and this goes for both at the EMA and at home, is if I know there's a storm coming in, I disconnect my coax from my radios, period. That way there's even less of a chance of anything happening. So if you're worried about it to that extent or you don't have the ability to spend a gazillion dollars like Greg on grounding, then disconnect your coaxes, take it off. That way you lessen the chance that you're going to have your really expensive equipment burned up. Not that I'll talk from experience or anything.
In my defense, I'm old and I have no debt. The house is paid for, the rent's paid for, the cars are paid for.
I'm just going to sit here and stick my tongue out at Greg.
Is my wife and dinner.
Okay, well,
Now Greg is of course going to get the fuss out right now, because I told him if he didn't bring Fred to the next filming of Ham Talk that I was going to fuss at him. He did not bring Fred. Where is my dinosaur? Greg, where is the dinosaur?
Going out. Horrible thing. He ran away from home.
No.
Yeah, it was. I sat there one day, I took food out to him in the backyard, and he was gone.
Which brings us to our pets of the pet episode.
That's right. So Fred,
Well,
the dinosaur, has left the neighborhood.
Everyone, please treat your pets well so they won't run away from you the way that Fred ran away from Greg.
This is an imaginary friend of his, right?
Yeah, it's a background. He's got this dinosaur. I started teasing him about being old as dinosaurs one time, like years ago when we first started filming Ham Talk. And it stuck because then he got this dinosaur background for when we're filming. And then he got this meteor background the next month. And then he tried to blow the earth up the month after that. So yeah, it's been a running joke, and I told him if you didn't bring Fred back, I was gonna have to fuss at him.
I'll apologize on Greg's behalf. Did you achieve the 100 ohm resistance?
Ooh.
Actually, it was 10 ohms.
10 ohms. Did you achieve it?
Yes, sir.
Okay.
Oh, nice. Good job.
That's why there's 12 ground rods.
All right, Miss Melissa, what do you have next for us?
Well, regarding that Tram 1481 and grounding it, Samantha, you took the words right out of my mouth because that's what I was going to suggest. It's like if you don't want to go to all that trouble and expense or whatever to put in the grounding rod and all that, that's what I do. I unhook it and I toss it out onto the lawn.
Now
And
I'm gonna make a suggestion on that, please.
okay.
Unhook it before the lightning storm reaches you.
Yeah.
Yes.
We have somebody, I won't mention his name, but
Oh, God.
every time it starts thundering and lightning, he says, I've got to go out and disconnect.
Uh-huh.
Like, dude,
Uh-huh.
you disconnected 30 minutes ago.
Yes.
And remember,
Yeah.
lightning can impact you 10, 20, 30,
Yes.
40 miles away.
Yeah.
Yeah. If you can hear thunder, it's already too late.
Right. Right.
So can I add a complicating question to the grounding inquiry earlier? Can I add a
Ooh,
question?
heck yeah.
Okay.
Yeah.
So how about a 60-second riff on earth grounding versus RF grounding? Which one of our tech experts would like to handle that one?
Yeah. Oh, go for
Well,
it.
actually,
grounding.
you've got 3 grounds. You got your safety ground, you got your RF ground, and then you got your lightning ground. That's how I always look at it. And your safety ground, that's through your outlet, although your power supply chassis may be tied to it, but that may not be tied to your rig. And that's to basically dissipate any 60 hertz energy and so on. The RF ground, that's a tricky one because what frequency are you at?
HF mobile.
HF mobile, you're not going to have much of an RF ground except for the body of the vehicle. But for household, you're on, say, 10 meters, and you've got an 8-foot lead going to your ground. Well, that's a quarter wavelength. Guess what? You don't have much of an RF ground, and that's actually a very elusive subject. And sometimes this is where the term counterpoise comes in, whereas if you put a quarter wavelength just wire from your equipment, and your equipment's all bonded together, that will ensure that your equipment remains at a current node. And as such, you won't have high voltages coming off. That's kind of the theory there. I'm sure somebody can dispute some of that, but when we start to get into grounding, things get really complex. And a lot of people see things in absolutes, and it's hard. Now, safety ground, I generally don't talk too much about because that's when you've got some towers or something. And I just pulled up the Tram 1481, by the way. And so as a VHF ground plane, essentially, performance-wise, you really don't even need a ground. That antenna it doesn't require a ground to operate. Now, you're going to dissipate some static, like Greg was talking about, charge, and that would be nice to dissipate. But when you get a lightning in your area, for sure, that's where you start throwing a cable out the window unless you really know what you're doing. Just get it out of the shack, get it disconnected from the equipment.
Yeah.
Now, see there, Melissa, I was going to feel silly bringing that up because I try and leave all of the technical stuff to those guys. Okay. But I was like, hey, it works for me, and I don't need to know a whole lot. You just take away the 2 parts you don't want blowing each other up. It seems very simple and common sense to me.
Right.
There is
No, you're getting a little too technical for our audience.
There is a third option. The third option is just to get ARRL insurance and leave everything plugged in.
Doesn't that just cover the
USAA.
equipment?
Okay, the ham man BS4KS also had another comment, and it kind of stole the thunder from Bandera Joe a little bit, but let me read BS4KS and then I'll read Bandera Joe. So he says, why do people dislike FT8 so much? What is the value to FT8 and what are the negatives? I have no working knowledge of FT8 and I'd like to learn more on it or more on why I should avoid it. And Bandera Joe comments, he says, actually he asks, you all have commented a couple of times. Now this is his words. You all have commented a couple of times about FT8 and your disdain for operating in this mode. Why? I use it all the time and I've made some incredible DX contacts. Why do you dislike it so much? So there you go.
First.
Well, let me,
Me first. No, me first.
I'm second. I'm second.
Okay,
Yeah,
my first one is I have sat in a 100-degree trailer on field day making phone contacts, and I have worked my butt off, sweated my butt off, and it feels very unfair for every 10 contacts I'm making on the phone for it to be 1 point. See this, I went over this in that last video we did. While the FT8 guys are making 100 contacts at 3 points apiece. And boy, does that just irritate me because I'm putting that voice effort in. So that's mine. Go ahead, JD.
Yeah, well, first of all, we don't hate any mode of emission in ham radio. That's a little strong. I think it's I'm coming around to the super ultra low power concept because I've got a meshtastic solar arrangement on order from a seller on Etsy, a really good guy that I'll be up and running with here in about by the end of the month. And I think Greg has one coming too. So that's kind of edging into the edge of this super low power long range communication. That's what LoRa stands for, LoRa. The thing about FT8 is it's kind of like beacon, listening to beacons, sort of, because it's really very automated. Sammy talked about the lack of phone and humanity on it. I mean, if that's what you're after, just logging node to node context, go for it. But it's just a little bit too dry for me. I'm done.
Well, I'll babble with mine a little bit here. First of all, Joe did an amazing job with the software and everything. What it accomplishes,
nothing against it,
is absolutely spectacular. And it incorporates into a lot of places. It's got a lot of potential. It opens up a lot of things. That said, during a contest, shut the damn thing off.
Yes.
I don't like the fact that, for example, during the VHF UHF contest we had back in June, if you looked at just a quick glance at the real-time propagation map, there were probably 500 to 1,000 contacts zipping all over the country. You couldn't get a single person on phone and everything because everybody was doing FT8. The other day, it was just a regular band opening. Had fantastic conditions. I talked to a guy in New York City, another guy in South Carolina, and then myself here in San Antonio. We had a beautiful round table. We stayed 5.9 plus on 6 meters for almost 3 hours. We could never find another station. Yet, if you looked at the real-time propagation map, there were hundreds of contacts being made. So I just don't like it. And I also, what I think they should do is have an FT8 contest.
Yeah.
And leave real people alone. And then by the same token, it shouldn't be allowed in like the June contest and things like that. That's my 2 cents.
By the way, By the way,
Yeah.
50 megahertz is the lowest that Greg will talk on. He will not go 8 megahertz lower than that because he's VHF and above.
You do
Am I
know
right?
that's inaccurate, right?
Mainly it's not inaccurate.
But 90% of my operating is 50 megahertz to now 5 gigahertz.
Well,
Okay.
All right.
So Greg redeemed himself. How about you, Andrea?
so I don't want to beat up on it too much. It's not a mode I'm fond of, but I understand why people do enjoy it. To me, there's not as much skill involved. But for people who just want to make contacts, and a lot of people are, afraid about jumping in and interrupting a QSO in progress. I know I had that problem, and it also yields some performance a little bit better than CW in some cases. Now, my experience on field day was a little different than Sam's. We made almost all the majority of our contacts were CW and phone. We did have a station running FT8, but they never just produced a whole lot of contacts. And I don't know, for maybe 10 contacts there or 20 contacts, I got something like 100 on CW. But I mean, people like it. And I don't care for how it has disrupted some of the VHF contests. There's some dedicated FT8 contests on HF, and there's dedicated mode, sideband CW RIDI, but for some reason the sponsoring groups insist on every VHF contest being every mode. And that's where some of the friction goes. Now, some of the problems that Greg alluded to about other people during the contests, one of the other factors is the assistance rule. So people aren't calling CQ anymore. They're just calling people, text messaging, calling up people on phone and say, hey, meet me on this frequency. And that actually was starting to have an impact before FT8 came out and kind of blew things up. But I don't know, maybe we need to do a segment on FT8 at one time. In fact,
we need a guest speaker. We need to get a hold of the guy that asked the question, Melissa, and we need to see if he wants to be a guest speaker to bring the opposite view.
Yeah, sure, that's a good idea.
Okay, I have a couple of more comments. And then we'll wrap up the show, y'all, because
I was going to say this.
I got a segment.
We filmed this one.
We still have to go to my segment. Just remembering.
Yeah. Yeah. Wait, I did that already. You can cut that in back when I talked to you.
No, we just talked about it and mispronounced it. We didn't do it.
Yeah, that's right. That's right.
Mispronounced FT8?
No.
No, quadrifilar.
You got it, Sam. You got it.
Oh. It was because of Andrea, I'm telling you.
Okay, Dale Ricketson 6461 says, good morning. I enjoyed the program. Another great, entertaining, and educational episode. Meshtastic seems to be a great EM-COM tool. In addition to coax loss, connectors is another loss concern that Greg clued me in on. I've had experience, like Greg mentioned, 6 open and no phone and CW happening, but F8 is active. I agree, digital should not be on the same playing field with phone and CW. Looking forward to the next episode, 73. And of course, Mike McDonald says, you guys should record your hamster club meetings and post them online too.
I agree.
And that wraps up comments and questions.
Darn it, I was hoping Mike would side with us too.
Well, then let's hop over to my segment real quick. I'm not even going to pronounce it. Let's just.
I said just pop it in where you just discussed I'm going to be doing.
We ain't going to do that. We're going to go to my segment right now.
Right now.
All right, guys, Dave's got a interesting antenna for us, so he's going to go ahead and do a presentation on what it is, what it does, why it does it, and why you want to build one. So Dave, thank you very much.
All right. Thank you very much. Most of you here know me, some of you don't. My name is David Fennell. I've been a ham radio operator since dinosaurs roamed the earth, or about 88 or so. A while back I was interested in doing some satellite communications, but I was living in an upstairs apartment, and most of the amateur radio satellite antennas at that time were not suitable for apartment balconies. So I ran into the antenna that I'm going to be talking about today. A little bit of background. I've been doing electronics and communications in some way, shape, or form for about 20 or 30 years now. I retired from the Air Force as the NCOIC of Radio and Television Systems for Headquarters Air Force News Agency. In civilian terms, I was the chief broadcast engineer for them. But anyway, getting on to what we're going to be talking about, it's an antenna with a rather funny name. It was originally theorized and partially developed by Dr. Kilgus from Johns Hopkins University, or the Johns Hopkins Research Center, part of the university there. And he had an idea of making an antenna that used quadruple helix, kind of like DNA, but with 4 twists rather than 2. So,
David, if you back up, I can't see the screen. For some reason, you're not opaque.
well, I am opaque. I'm just not transparent.
This is clear.
So, anyway, so we're going to be talking about what's known as the Resonant Quadrifilar Helix Antenna, or as I just like to shorten it, Quadrifilar Helix Antenna, or QHA. And this is an image of my very first prototype of this antenna, and it worked remarkably well. Here are some of the properties of the Quadrifilar Helix Antenna. It is extremely small for the performance it provides, and very shortly I'm going to show you exactly how small it is compared to comparable antennas. It is circularly polarized, which means that if you're vertically polarized, the antenna likes you. If you're horizontally polarized, the antenna likes you. The only time it might disagree with you is if you're polarized left hand and you built a right hand polarized antenna. But for most situations, it doesn't matter if you're vertically polarized, horizontally polarized, the antenna is going to work. It is ground plane independent. A lot of antennas like having a ground plane to refer to. It doesn't care. It has excellent beam shaping capabilities, and I'll get into that on how you can change the characteristics of the beam based on the characteristics of the antenna. And it doesn't conform to standard helix antenna properties. Normal helix antenna, which you've seen with a helix going off of a ground plane, the sense of the polarization is the sense of the helix. Here, this antenna here is right-hand polarized, but if you notice the helix is going to the left. So the circular polarization is exactly opposite of that of a traditional helix antenna. Let's see now. Size matters. Here are 2 antennas. The one on the right is a flight model of cross dipole over ground plane. And the little tiny antenna on the person's fingers on the left is a quadrifilar helix antenna. Both of these antennas have the exact same beam characteristics, polarization, and gain. And when you're dealing with spacecraft, size and weight matter. Which antenna do you think NASA would prefer sending up on a spacecraft?
Oh, the big one.
So to give you an idea of the performance that you can get out of a little tiny antenna, these are two antennas that basically have identical characteristics as far as RF goes, just that one is substantially smaller. The way the standard quadrifilar helix antenna is developed, you start with a horizontally polarized square loop, which I'm sure people are familiar with when they studied for their amateur radio license. And then you give it a twist. And this here's the current going through the twisted or a bifilar helix antenna. And this here's would be a 1/2 turn bifilar helix loop. And then to get the quadrifilar helix antenna, you take two of those loops, you superimpose them over the same space, and you arrange them so that they're just lined up with each other but twisted 90 degrees. So, and this here is what it looks like, and I can pass this around. This here is a prototype I'm working on for 70 centimeters. So you can basically see a little bit what it looks like here. One of the drawbacks that I think of this antenna, at least in the design phase, is unlike most antennas where you just have two feed connections, where you have basically the shield in the center connector or something of that nature. This antenna has 4 connections that you need to connect to it, and it needs to be fed in phase quadrature. And does anybody not know what that means? Okay. When you're dealing with waves of any type, but in RF waves, if you take a full wavelength, you consider that 360 degrees, if you remember geometry or trigonometry from high school. What phase quadrature means is that you're going to take the RF wave there, and at each 90-degree segment along that wave is going to be one of the feed points on the antenna. So where normally most antennas you feed it with 0 and 180 degrees, this antenna you feed it with 0, 90, 180, and 270 degrees in order to make the antenna work. So the antenna does require a little bit of a feed network before the antenna to make it work. Did everybody understand that, or did I confuse everybody? Yes?
If you swap them, got the south on 270 and the north on 190, if you accidentally swap them, would it still work?
Yes, it would. And but what it'll do is instead of the RF radiation going from the top of the antenna, it'll point it down into the ground. Or, but the antenna will still work. Yes. It's just that depending upon if you're going left to right or right to left, it depends on which side of the antenna it comes out of.
Might work like a distributor in the car and keep that thing rolling.
Yeah.
So if you had an antenna way up into space, you could point it down, but turning it the other way.
Absolutely, and we'll get to that.
Okay.
But also, with the antenna that I originally designed, and I found out something out later, if you put the feed point at the top of the antenna and feed it backwards so that the radiation goes up and out, there are some benefits to that, because if you put the feed point at the bottom, it'll have a little bit of an extra lobe at the bottom, where if you feed it at the top, it absorbs the load and adds the lobe to the main RF envelope, if you want to call it that. So, but anyway, this here is how the original antennas were fed with this degree here, with this configuration here, in order to feed it. I have basically the same thing with my antenna design, just done a little bit different. The one on the left is how I chose to create the feed for my antenna. And I hope you understand it. I've never tried the one on the right, but the one on the right would work, but it would change the impedance of the feed point, so I'd have to do some other work with that. But right now, the one on the left is how I have my antennas currently fed. or the 2 meter antenna that I designed. As I said, the antenna needs to be fed with phase quadrature, or you have to do something in order to get a quadrature RF field going on. There's more than one way to do that, and one alternate way is using, let's put it this way. This here is an infinite loop balance, so people know what balance are. And one very elegant way to design these antennas, if you're good at the math, is create a self-phasing quadrifilar helix antenna. And the way that is done is you make one loop.
No, go down that way a little bit. I keep moving back, but I'm running out of room.
Oh, I'm sorry. Okay, yeah, you don't want to stand in front of it and block everybody.
Yeah, no, right there is fine.
Okay, so, but anyway, what you would have is you'd have one loop larger and one loop smaller than the other. And by doing that, one loop is inductive and the other loop is capacitive. And when they work together, they create your phase quadrature. And that's self-phasing quadrifilar helix antenna. And you have two loops of differing sizes. One loop is smaller and it's inductive. The larger loop is capacitive. The reactive component of each loop must equal the resistive component for 45-degree phase, for a 45-degree phase angle. And the conductor diameter is critical. I'm not that good at math, even though I'm an engineer. I decided to do, rather than a self-phasing quadrifilar helix antenna, I chose to do an externally phased quadrifilar helix antenna. So that's why I did my design choices the way I did. If you want to take on a self-phasing quadrifilar helix antenna, what's neat about it is that you'll only have one input signal, which is your piece of coax here, and the other legs of it are just conductors of the same diameter as the coax of one half of one of the loops. Now we're going to get into Smith charts. So, and most people who have put Smith charts on an antenna know that it typically goes in a little curly Q and stuff of this nature, or goes in circles. But with a self-phasing quadrifilar helix antenna, not mine, but a self-phasing one, you get a trace where the resonant frequency is here, but it goes out, it doesn't, most Smith charts won't form this little sharp point here. Most Smith charts on most antennas will just do circles. Because mine is not a self-phasing quadrifilar helix antenna, it has a Smith chart more in line with normal antennas. And here's the Smith chart for the antenna that I designed. So in here at number 1, we have a starting frequency of 144 megahertz. Number 2, ending frequency of 148 megahertz. So that covers the 2 meter band, and it's fairly well centered. So it's a pretty good performing antenna as far as resonance across the 2 meter band goes. Talking about radiation patterns, which I mentioned before. If you take the antenna, just sticking up vertical, this here is what the radiation pattern would look like when illuminated with another circularly polarized antenna. Now I told you that the antenna doesn't mind if you feed an antenna at it with linear polarization, vertical or horizontal. So what they decided to do to demonstrate this is they illuminated one of these antennas with a spinning dipole. So you could see how well it performs there. And as you can see, you have the little nodes here from where the antenna is spinning a little bit, but overall, the antenna still has roughly the same radiation pattern. So when it works with a linear polarized antenna, it still performs very well.
So you're talking about actually turning the antenna. You said spinning.
In order to create this radiation plot, they took a dipole antenna and they spun the dipole antenna while rotating this antenna in order to create the illumination pattern or radiation pattern for this antenna and how it would interact with a linear polarized source. Does that make sense?
No.
Okay.
I'm trying to visualize how they rotated it and not twist off the coax.
That's not my problem. I'm just telling you what they did.
Oh, okay, okay. You haven't done this.
No, but actually if you take a BNC connector, you know, you can spin BNC connectors. So, you know, they could have just put the antenna on a BNC connector and, you know, spun the antenna like that and it would probably work. So I'm sure they did something of that nature.
Okay.
So
Why would you want to do that? To spin it?
to spin the antenna?
Yeah.
Because dipole antenna is a linearly polarized source, and the quadrifilar helix antenna is circularly polarized. And if you want to see how well the circularly polarized antenna will perform with other antennas that are linearly polarized, you would want to see how that antenna performs with a vertically polarized antenna, horizontally polarized antenna, and everything in between. So in order to do that, in order to do those measurements, they'll spin one antenna in order to create this plot here.
Okay.
So anyway, I mentioned that the beam characteristics could be shaped fairly well with this type of antenna. As I said before, this here is the radiation pattern when illuminated with a circularly polarized source, and if you add 5 dB to these values, you get pretty decent gain, where the greatest gain is 5 dBi. So that's pretty decent gain for this antenna. But if you notice with this antenna here, most of the gain is going straight up, which is great if you're doing satellite work. But if you're trying to do terrestrial communications, you may want something spread out a little bit more flat. And there's a combination of things that you can do with it. To do that, you can make the antenna long and skinnier, or even to make it longer and skinnier still, you could go from a half wavelength antenna, which that one is, and the one I designed, and go to a 1 1/4 wavelength antenna, and instead of a half a turn, do 1 1/2 turns. And doing that, you'll get a beam characteristic of this, where you have a lot more illumination towards the horizon. So just by making some slight modification, design changes to the antenna, you can change the beam characteristics of it substantially depending upon what your purposes are. Did you know that amateur radio operator has a zombie satellite? Okay, this is Oscar 7, and it was launched in the 70s sometime, if I remember correctly. And a few years after it was launched, the batteries on it shorted out, so the satellite died. And people thought it had just disappeared off the face of the Earth. Then after about 10 years of being in space, which is a rather dry environment, the batteries dried out and opened up. And when the batteries opened up, it no longer shorted out the solar panels on the satellite, and the solar panels were able to provide power to the satellite when it was in view of the sun, and the satellite turned itself back on again. And then someone was hearing some telemetry information from space, and they didn't recognize this telemetry information, and they're like, what is this? Where is this coming from? And they had to go back in history to figure out what this telemetry was, figure out how to decode it, and they go, this is that ancient Oscar satellite, and now it's back working. And like zombies that have an affinity for brains, unfortunately Oscar 7 has had some control issues as far as its control computer goes, so it needs help with brains. So whenever it starts up again, it starts up in a random mode, And sometimes you can use it, sometimes you can't. But Oscar 7 was one of the amateur radio satellites that also used this type of antenna on it. And it used it for the microwave beacon. And in this image here, this little tiny antenna down here is the Quadrifilar Helix Antenna. And here's a better image of it on the satellite before it was launched. So yes, if you have kids or anybody like that that have an affinity for the zombie craze and stuff like that, you can tell them the amateur radio operator deals with the zombies as well. So we have our own zombie satellite that you can use. And I think it has an uplink on 2 meters and a downlink on 10 meters, if I'm not mistaken. So, but anyway, you were talking about putting these antennas in space. Well, they're not only on amateur radio satellites. This here is the Quadrifilar Helix Antenna on NOAA 17, which is a weather satellite. And it's at 137 megahertz. So it's basically a 2-meter Quadrifilar Helix antenna as well. And even though the center frequency of the antenna that I designed is 146 megahertz, not 137 megahertz, I have used my antenna to pick up NOAA 17 weather facts and from the other weather satellites out there. So it works as a good receive antenna for these satellites. Now, I'm going to get into details as how I got drawn to the Quadrifilar Helix antenna. As I was mentioning earlier this evening, like a lot of kids and a lot of individuals, I find space pretty cool, and I like.
Very cold.
I'm sorry?
You said cool, very cold.
Okay, if you say so. But anyway, knowing that amateur radio had a constellation of satellites that we could use up there, I thought, gee, it would be pretty neat to start using some of these satellites. But at the time, I was very poor and destitute, and I was living in an upstairs apartment complex, and I just didn't have the space to be able to talk to all of these different amateur radio satellites that are up there. And here are images of a lot of the amateur satellites that we've put up in space. And the reason I couldn't talk to them is because at that time, to the best of my knowledge, most amateur radio operators needed antennas of this nature in order to talk to them. And these antenna systems really don't do well on a tiny apartment balcony.
If you can put the one array up there on your apartment balcony, you got one hell of a balcony.
Exactly, you know. And around this time, I had been sent to advanced broadcast school at Fort Meade, and this is also about the time when the first civilian GPS units were coming on. And I bought one of these Magellans that you see on the left. And I was thinking to myself, gee, this GPS thing is capable of receiving satellite signals, and this is a little tiny handheld thing. So I don't need this huge antenna array. And if you've ever worked satellite communications, you know the most challenging part is receiving the information from the satellites, not actually hitting the satellites. And that's because the satellites are limited to have a serious power limitation because they're running off of solar power. You can't plug a satellite into the mains and give the satellite all the power it needs. So they don't really have really high power transmitters or anything. So I was thinking, gee, if this little tiny thing can pick up these satellites, you know, I wonder what it uses in order to pick up these weak signals and stuff like that. And I figured one of the things that it would have is probably a pretty good antenna. And I looked on the back of it, and it said it had something called a Quadrifilar Helix Antenna. I'd never heard of that before. I looked in my ARRL handbook, it didn't mention it. I looked at the ARRL antenna book, it didn't mention it. And
That's Mr. Google.
well, you know, this is
'74.
this is also the dawn of the internet. But anyway, the internet was going a little bit at that time, at least. And I called my dad, who's a retired microwave engineer for the government electronics group at Motorola. And all he told me is it had something to do with 4 wires. And I'm like, gee, thanks, Dad. That's a lot of help. But I did do a lot of research with Google, and I came upon a page from a Walt Maxwell. His call is W2DU. And unfortunately, he's now a silent key. But he used to work for the RCA Space or Satellite Division. And he was part of the engineers that designed Oscar 7 and the Quadrifilar Helix Antenna on that satellite, among others. And he has an outstanding book that I highly recommend people pick up, and it's called Reflections. I'm sorry, I'm getting out of your field of view here.
You're okay.
The book is called Reflections, and there's now 3 editions to it. So the latest and final edition was Reflections 3, and he had on his website at the time posted the chapter about the Quadrifilar Helix Antenna and the appendix, and with the information that he posted there, it gave a very, very outstanding description of the antenna, how to build one, this sort of stuff. And using primarily his information is what allowed me to design the antenna that I did design for 2 meters. And I did purchase the book. I don't know if it's legal or not, but I have seen the book available for download on the internet. So you could use Google, see if you can find it. As I said, I purchased my copy, and you can actually learn a tremendous amount from it, and a lot of the information in the book, most ham radio operators would be shocked at. And one of the things that it talks about in the book is that SWR is not as important as most hams make it out to be. In fact, a lot of the antennas that he was designing for NASA and RCA actually had a high SWR. Yeah, absolutely brilliant book, highly recommend it. Here are some of the design considerations that I had to take into account. The radiation pattern, whether I wanted to do a self-phasing antenna or externally phased. I told you why I went with externally phased antenna. I needed to calculate the aspect of the ratio of the antenna, height versus width. And I wanted something a little bit taller and skinnier than the standard one, because I did want to get a little bit more gain towards the horizon. I wanted to know whether or not it was how many turns I was going to have on the twist, and the wavelength of the antenna. Also needed to consider what materials and tools I had. As I said, I was stuck in an apartment complex. I didn't have access to a machine shop or a garage or anything of that nature, so I had to come up with a design that I could pretty much build with fairly small tools in an apartment. I didn't want something super complex or anything of that nature, and at the time I was dirt cheap. Now, one thing I did at the time also is I wanted to see if there were any commercial antenna manufacturers that made this type of antenna for the amateur radio bands, and I wanted to have one with a center frequency of around 146 megahertz, right in the middle of the 2 meter band. And most of the companies that were making this type of antenna were making it specifically for downloading weather facts off of the NOAA satellites. They weren't considering amateur radio operators as a serious client base. But I did find one antenna manufacturer that said that they would design one and make one for me for 146 megahertz. They only wanted $1,000 for it. And I consider that a lot of money today, and back around 1997, that was a lot more money at that time. So I said, I'm doing electronics, I can design this thing and build it myself for that. So that's what I did. And the radiation pattern I chose would look like a drop of water on a piece of glass, basically, is the radiation pattern from my antenna. Externally phased, I had an aspect ratio of the antenna of roughly 2.4 to 1, and it was a half wavelength, half turn configuration. I used PVC and mostly 6061 and just plain pure aluminum that I was able to get at Home Depot and stores of this nature. Complexity, the antenna complexity was not as simple as a dipole, but it was a lot simpler than a lot of the other antennas out there. And at the time, the supplies cost me between $20 and $40. Today, the supplies would probably cost someone about $50, $60 with inflation, especially over the last 4 years. Here's actually an image of the scribble math that I quickly did in order to design the antenna. And this here is the final result. Now, as I said, I designed this probably around 1997, 98 time frame. But in 2017, the ARRL announced that they were going to have an antenna design competition. And my dad was very familiar with the antenna that I designed here, and he thought it was a pretty good design, and he twisted my arm saying I need to enter my antenna into this antenna competition. And I'm like, at that time, I didn't have all the plans written out in detail or anything of that nature. All I had was this sheet of paper here, you know, that I did save, but I didn't have it written up with detailed plans on how to build it or anything of that nature. And it was going to be a lot of work to enter the competition. But I decided to go ahead and read the rules and enter the competition. And lo and behold, QST and the American Radio League sent me this here, saying I got second place for the 2 meters or the 6 meters and up antenna design section of the competition, and I was very proud of that. But what was even nicer, considering of how I was, how poor I was still at the time, is they sent me something that I was unaware that even existed, and this actually really shocked me. This here is an actual image of a check from the American Radio Relay League. Most people are, and this went towards the payment for my life membership, which costs a lot more than this, but at least this helped pay for it. So, and they actually sent me 2 of these checks, one for winning second place in the competition, and one for allowing them to print the plans and do a write-up on it in QST.
I remember your article in QFT or CQ magazine, one or the other.
It was QST. It was the May 2018 issue. And I'll call up the article here after this. But right now, does anybody have any questions? Yes?
Why do you use flat straps instead of round wire?
Well, I just found it a little bit easier for the mechanical design that I was building at the time. And I was also looking at the design of how other people had designed some of the other quadrifilar helix antennas. And some of them were using coax for the elements. Some of them, I wanted something to look a little bit more professional as well. So that's why I went with the flat straps as well.
I just thought maybe the flat strap made it think it was like a wider tube rather than a wire or something.
Well, it does that as well. You don't want to use too thin of elements because then it will not perform the way it's supposed to. So you do need to have a little bit of diameter for the elements.
I think the flat strap looks really professional.
So, any other questions?
So now we know.
There you go. You should be an expert on what we can't pronounce.
The proper pronunciation is, and then it fades to black.
We are going to be touching a little bit more on future episodes on two things. Number one, we are getting more and more, the hamster group is getting more and more with meshtastic, and we're promoting it with the Aries group and our own group. And in fact, we're fixing to create a hamster channel for meshtastic, where we'll be sending out like band opening alerts, meeting reminders, and things like that. So, you know, we're kind of getting more involved with that. We're also working with the local Aries group to enhance the emergency system to communicate a little bit. And we're actually getting, I'm going to tell you right now, I have a lot of experience with 900 megahertz single sideband and 900 megahertz FM repeaters. I had very little expectation of success when I first was introduced to meshtastic. Jack K5AJ bought one, met me for breakfast, showed it to me, went over the wonders of it, and of course he had just gotten it, had no knowledge of it yet. So our conversation was entertaining. We're sitting in the restaurant 2 days ago with that unit, sitting on the thing. He bought another portable one, sitting on the table in the restaurant. He is linked and connecting to his house 5 miles away. And we had, I think, 19 nodes that we were connecting to inside the restaurant there. His one at his house is actually connecting to nodes 19 and 24 miles away.
Let me ask a question about that. I have a diamond 33 centimeter 927 megahertz antenna cut for the 900 centimeter band. And I guess that would probably be the ideal antenna to put back up on the arrangement on the roof versus the little stubby rubber duck that comes in these meshtastic units.
A lot of people are doing that, but you need to keep your cable about this long. Come right off of that stubby little antenna thing with about a 3-inch cable and plug in, because the losses when you're only talking less than 100 milliwatts is pretty significant if you put 5 feet of cable in there.
Okay, so probably stick with an in connector rubber duck as a good compromise between the two thoughts then.
No, they should come with an SMA. Just get it.
I mean, you don't want SMAs at those frequencies if you can do end at those frequencies, right?
SMA is going to be just fine.
Okay.
And Greg, I just want to point out dBs is dBs, no matter what your power is. And yes, that you may be starting at a low amount in terms of link, but if you lose two dBs, it's probably not going to kill you.
That's true. But, you know, a lot of these antennas that people are doing, we demonstrated that a while back. One of the guys picked up a high gain 900 megahertz antenna off of eBay. I'm not going to mention the seller or anything like that. When we hooked it up, he was really disappointed it wasn't communicating better than the rubber duck on it. And when we measured it, for one, it was not resonant. It was resonant at 830. And its gain was not anywhere near what it was advertising. We'll just leave it.
Well, 830 is not 33 centimeters. It's not.
I'm aware of that. That's part of the problem that I'm
I was going to say, he's probably not trying to say what he's trying to say.
I'm trying to be diplomatically polite.
Yeah.
For
once.
I soldered a SO239 on my butane tank in the backyard, and it wasn't resonant either. So, think about that.
I think that it's time to hear Andrea's funny story. So, Andrea, tell us about your hotel room experience.
Before I get to that, let's see. One, I want to make a shout out to Leo, KD0LIM, a viewer of ours who I met at Central States VHF conference a couple weekends ago. Now, there was some sad news at that conference. We got word that Marshall K5QE passed away, and he didn't make it up to the conference. And reportedly, somebody said, I'd rather die than miss the conference. So he died. But so unfortunately, he runs or has had a very large contest station with 3 large EME arrays, and actually he had a 4th one, 1296, just a dish, a whole bunch of antennas and stuff. And I've operated at that contest site, and I've talked about that before on the show. So we'll all miss him, particularly in the eastern half of Texas here, where that was a big VHF station on the air during the contests. So that leads in.
I'm sorry.
Go ahead.
Yeah, Marshall played a key role in my development on VHF, UHF. I was just in the dabbling stages when I got to go meet him, and he gave us JW5GNA and myself a private tour of his contest station, and then we got to do some operating on it. We made an EME contact while we were out there, and a few other things. Marshall's contest station was incredible, and he's going to be majorly missed in the VHF UHF world. I don't know what the plans were for his contest station, if it was moved to a club or anything, or if it's just died with him. But both of those are a huge loss, and Marshall's going to be really missed in the VHF UHF world.
If you guys can look into it and bring us that update in a few months, once they perhaps decide what's going to happen with it.
I can already speak to some of that a little bit, because so there is an intent to operate the station in the September VHF contest. There was also talk of getting a club, which would allow getting the call sign, although that probably can't happen before September. Where it goes after that, I think one of the challenges, of course, is maintaining the station. I don't know what Marshall's wishes as far as that goes are, but there's people to do some work there or willing to, but I mean, that was not a cheap place to run.
No.
There's
electric bill alone.
Yeah, well, you got the electricity, the property, whatever taxes. And one thing about a large contest station is there's a lot of stuff to break, and there's a lot of stuff that is not cheap. So what's in the further future, that's really hard to tell. I do want to speak a little bit on Marshall. Marshall is people would say he was mildly opinionated. And
no.
None of us are that. None of us.
And people would often get along with him, or absolutely never want to talk to him again. But he did a lot. One of the things he typically had done through the years was the VHF 101 talk at a number of these conferences, really geared to the beginner, people just getting into it. And I guess I'll make the point there that these conferences aren't just for people that are very accomplished. There are tech papers that go into advanced topics, but there's stuff there for the beginners as well, and networking a lot of people. Also want to mention that I first met Marshall well, sort of on the phone in 2016 when I was doing a row from Pennsylvania to Texas. And I sent out blind emails to the top scorers in the various areas asking information about, well, one, letting them know I was going to row through their area so they can keep an eye out. But two, asking information about operating practices and such in the area. I got a quick response from Marshall, call me, in his phone number. And we talked, and he provided a lot of good information. And I've also have had others that have reached out from that same email blitz that have helped me through the years. So he will definitely be missed. Proceeding on to the topic here you shanghaied me into, I did go to his services, which were in Hemp Hill, Texas. And to avoid having to drive long distances, I stayed out there. And I knew I was going to have an adventure when I saw the price was $51 from the local motor lodge. And so I put a review. I gave them 5 stars, but the review starts out something like this. All this place needs is to be rebranded from a motor lodge to a exotic boutique hotel offering a unique theme stay. The mood
was that by the hour or for the evening?
That was for the evening.
Oh,
So the mood was
But
set.
you had to go down and pay
It sure felt that way.
It was not that popular. Let me put it that way. Okay. All right. It was not doing hourly trade just because. Let me get through this. All right. So the mood was set when my GPS told me I was there, and I couldn't see anything, but did notice far off the road a lighted parking lot. And that's when I noticed the unlit, overgrown sign for the place. Drive down this long driveway, and I pull up under the canopy like a lot of places have. I go and look at the door, and there's a sign that says closed. No rooms after 10 p.m. And I look at my watch.
Why does this sound like a screenplay for like a cheap chainsaw massacre?
I was going to say Hotel California.
Hold on. I haven't gotten to the least of it yet.
Oh, God.
All right. So I'm looking at my watch. It says 10:03. And I'm like, crap, this room's prepaid. I mean, and the nearest place, because there's nothing around there, is like an hour away. Maybe there's something in Many, Louisiana, but you got to watch out because there's the many tigers. But that's another story. So anyway, I'm starting to look at my phone, let's call this number because it was under Choice Hotels. They got an actual number, right? And this woman comes to the door. She lets me in. And I should say, it looked like the ceiling was collapsed in the lobby. It wasn't, but there was a lot of like construction-y things going on. And it looked pretty run down, to be honest.
Like fake walls where they put the
so it turns out, according to her, she's the owner, the sole employee. For all I know, she could have been just a squatter. But she did get me a key to the room. The computer didn't work, so she did some magic with her phone and somehow produced a key card for the room. And I go down the hall, and the motif continued with like step ladders. A third of the rooms had the doors propped open. There were sheets hanging. A whole bunch of the ceiling tiles were missing. When I get to my room, I open it up, and boy, that mood continued because walls were surgical scrubs green with a blood red accent wall.
Okay. Do we need to do a GoFundMe for your motel budget when you travel?
Yeah, I think so.
Here's something that comes in mind here. Does anybody ever watch back in the day Married with Children?
Mm-hmm. Yes.
Remember when they stayed at a hotel and they're like half the population in that town was trying to kill them?
Yeah.
Okay.
I'm going, Andrea, no, I wouldn't have. No, I would have slept in
No.
my car.
So,
I would have
like,
stayed.
okay, the refrigerator was white, but it had some marks that looked like blood had gotten on it and just wasn't completely wiped off.
I mean, you can't make my. Yes, I mean, was there chocolate mint on the pillow at least?
Okay, so you definitely got the impression that there might be a severed head in it. I didn't, and there was not one. The air conditioning was on full. It was chilly. It was like walking into a prepped surgical suite.
Because they were trying to keep the body from smelling.
Yeah,
and a meat locker.
And you know, you sort of got the sense that you shouldn't drink the water, so I didn't. The sheets were nice and clean, and the bed actually was pretty comfortable. I slept like a corpse.
Yeah, you came close to it. You know, in fairness to this hotel, Andrea is probably one of 3 guests that year.
No, there was about a half dozen cars in the parking lot. So
Hotel California. No, they checked in and never checked out.
Yes. So the owner, proprietor, squatter, whatever, told me when it's time to check out.
Color.
Just leave the key because she won't be around. Really made me wonder whether she might be a vampire.
Back to the shovel.
And let's see. Just to kind of finish out everything in the morning, when I went outside, that place was more run down than I realized. I mean, and yeah, it's and so
It really scared you.
I'm gonna send you some Marriott points. I'm just gonna send them over.
I'm gonna send you all my points too.
Okay, the same closed sign was on the door, and the door was locked. This was like about noontime. And so I just kind of slipped my key card through the crack in the door. I left off my my review with this little statement here. It says, if you are into ghost hunters or just like to live on the edge, this place might be for you.
And she tied that in because she was there for K5QE.
Yeah, absolutely.
I had to figure out how it was connected with amateur radio.
That's how she did it.
Hey,
I was there for K5QE. So,
you know, one thing I'm going to say that I'm really thankful that I got to know Marshall, K5QE. I learned a lot from him back in the early 2000s when I first started transitioning to VHF, UHF off of HF. And I was also blessed. I don't know if you ever met Bill Tynan, W3XO, Andrea. He was another who's who of VHF, UHF operating, and also one of the key founders and promoters of satellite amateur radio. He was responsible for helping get one of the first satellites and stuff up.
Oscar, I think, or whatever it's called.
Yeah. If you ever want to read an interesting biography, just type in Bill Tynan or W3XO, and there's his biography and story. Is fascinating. Some of the things he accomplished.
So I know that Greg has a net right after we shoot the show. So let's go ahead and wrap this up. at least this month is going to be entertaining. Andrea does not fail to deliver. I'm telling you, I'm going to start tapping her to end all of our shows. I got the opening. She's got the close. We're good to go in between.
And I've got one more thing too.
Sure.
I think I'm going to come out here. There we go.
Make 1.25 meters great again.
225, 222 megahertz. Great.
I like it. I like it. All right. One more thank you to our sponsors, the Hamsters Week Signal Group. We're hoping that they'll move forward with all the plans they have and take some of our suggestions to get some more shows on, maybe video their club meetings, because it sounds like there's a lot of people that are interested in what goes on at the meetings and the information that they can gather. All of our contact information will be down below, and I'll have Melissa kick Greg in the shin if he doesn't get it down there, including the email addresses that you can send your comments or pictures of your shack to for Melissa, questions for all of us. If you don't want to put them out in the public eye, you can always just email them to us and we'll touch on them later so that you can stay anonymous, because there's a lot of people out there that don't want to attach their name if they don't know what they're talking about and they want to learn. So thank you guys for a great show. I won't do final thoughts because poor Melissa always feels put on the spot when I do that.
I got nothing.
Well, I'm gonna throw a
nothing.
final thought in. If you're in the San Antonio, Central Texas area, Mondays at 7 p.m., we have a big simplex net, and we have check-ins for 200-300 miles sometimes on 146-520 simplex. Join us.
All right. There you go, guys.
So there's a little bit of propagation showing up. I'm going to point my beam down that way and fire up the Beco, get as much power as I can, and see if I can slip in there tonight.
All right,
Awesome.
we'll listen for you. All right.
So thank you all for tuning in, and catch us again next month, where we're hoping Andrea will have another gruesome, horrifying, hilarious story for us.
The Hemp Hill Chainsaw Massacre.
Right. Bye, guys.
Bye, guys.
Bye-bye.